This is Katie Kimberling with TutorPUG. I wanted to do part 3 in my U-Substitution series on some more difficult or test level difficulty problems. So if you feel like you're proficient with U-Substitution, by all means jump in here. If you feel like you need a little bit of refresher, go back to the second video. If you feel like you need a lot of refresher and you're not even sure what U-Substitution is, start the series with the first video. This particular problem, the u is going to be x to the negative 1. That's step 1, is to identify u. Step 2 is when we derive both sides. So I'm going to drop that exponent down and subtract 1. That's what I call drop and flop when we're deriving. And that gives me negative x to the negative 2. Even though I said this is not an algebra problem, a lot of these U-Sub problems do require some algebraic skills. So you have to recognize somehow that this negative x to the negative 2 is essentially almost the same as, except for a negative sign, 1 over x squared dx. Because this can be rewritten, first of all, using my rules that I mentioned in the second video. This x to the negative 2 can be put in the bottom or the denominator of a fraction. And if I do that, I change the sign on the exponent from, in this case, a negative to a positive. And I still have the dx. So when I'm ready to come over here and do my third step in U-Substitution, this particular portion, the numerator, becomes e to the u, and what that leaves me a 1 over x squared dx to get substituted or translated. And over here I'm close, I have a negative 1 over x squared dx, so if I just divide both sides by negative 1, then that tells me that 1 over x squared dx is negative du. And now I have that in the form that I can antiderive. So the negative comes along, it's a constant out in front. The antiderivative of e to the u is e to the u plus c. And then for our fifth step in U-Substitution, we resubstitute what u is really holding the place for back into the final answer. So my final answer would be negative e to the x to the negative 1 plus c. And then, like I said in the other videos in this series, you can derive this, you can find the derivative of your answer to see if this is the correct antiderivative of that problem. So if I antiderive this, I am going to, it's a chain rule. I have an e to the blah, so the first thing I have to do is recopy e to the blah, and then I multiply it by the derivative of the blah. Well, the derivative of x to the negative 1 is negative x to the negative 2. That negative and that negative multiply to give me a positive, so they cancel. And this x to the negative 2 says, oh, that portion can move to the denominator, and I can change the sign on the exponent. So this simplifies algebraically to that, which is what I started with, which means this is the correct, or I'm sorry, this is the correct answer to my original U-Substitution problem. So let's try a second one, and you can see that magically appearing over here, I have put a handful of our antiderivative rules, so we can sort of use that as a target of where I want this to go when I do that third step translation phase, to see if I can get this, which won't antiderive and which can't easily be simplified via algebra, into something that I can antiderive. So I want it to follow one of these simple patterns thereabouts. So in this case, one of these is going to be the derivative of the other. That's how I can identify what u is. And like I spoke earlier in another video, if you have separate terms being raised to a power or separate terms under a radical, that's a good place to start for you, especially if you're trying to get something like this to turn into a different term that doesn't have a constant. Because the derivative of that constant is 0, it will go away, which means I can account for something that doesn't have plus or minus a constant. So in this case, u is 1 plus the square root of x. And if I want to think of that as 1 plus x to the 1/2, I can, because the radical turns into the 1/2. Go back and refresh your algebra rules in video 2. Second step is I derive both sides. The derivative of 1 is 0, it goes away. The derivative of root x, or x to the 1/2, is 1/2 x to the negative 1/2, and we have to put that dx. So now I'm looking, I have sort of the dictionary, the translation dictionary that I've created, and I'm looking over here to see how things would translate. And I know that this piece would turn into 1 over u, and the u would be squared. But that means I still have this guy to mess around with, and that's where I look to du, is that helps me figure out how that guy is going to translate. So again, like I spoke about in the previous example, this could move to the denominator and become positive, and that could then convert to the radical. So that gets me really close to the 1 over root x dx. I just have a 2 in the denominator here that I don't like. So if I multiply both sides by 2, then I know that 2 du is 1 over root x dx. So all of that is steps 1 and 2 in our 5-step U-sub process. Now I come over here to step 3 to do my translation. This becomes 1 over, that piece is u, that piece is squared, so my u is squared. That piece is in the denominator, so the squared u is in the denominator. And then my 1 over root x dx becomes 2 times du. And I have a rule for that. This, even though it doesn't quite look like it, is actually this guy, because that can be rewritten as u to the negative 2 du. And now it fits this pattern, which is a variable base to a numerical exponent. So I add 1, negative 2 plus 1 is negative 1, that new value goes in the denominator, tack on a plus c, and then our final step is 2 times what u was really holding the place for, 1 plus root x, pop that right in there, to the negative 1 over negative 1 plus c. And then if you want to, you can derive that to check it. You'll have to use chain rule. There's nothing wrong with that. But the derivative of this gets me back to my original answer, and that tells me that I have done this correctly. I'm putting some extra problems down in the show notes, and you can find a key. I'll put directions to where the key is in the show notes, in the problems in the show notes, and you're just going to have to keep practicing. There is no substitute for persistent practice on U-substitution. Happy mathing and good luck.